Well, hello and welcome to another DevNation Live Tech Talk. We're coming to you live streaming right now, in my case coming from Raleigh area, North Carolina. I don't know where Josh is. We'll get him to say in a moment. But Josh Wood is one of our lead developer advocates here at Red Hat. He's going to talk to us about operators and the Operator SDK and the OLM, which is the Operator Lifecycle Manager, and all kinds of good stuff, and how it applies to your Kubernetes cluster. He's actually a famous author. He should say that in a moment or so. He's a famous author of an Operator SDK book, and he's going to talk to us about that. And he's also a public speaker on the O'Reilly network, if you're familiar with the O'Reilly world. So we're going to have a lot of fun with Josh over the next several minutes. Do feel free to throw your questions into the chat. I see DJ Maddie's already here, ready to rock, so it's good to see you again. And feel free to throw your questions at Josh on the fly into the chat, and we'll relay them in a second. But Josh, at this point, we're going to turn it over to you.
Hey, thanks a lot, Burr. So let's answer two questions off the top. I'm in Kansas City, Missouri, where I'm from originally, and where after living my whole life away from here, I recently moved back. I've been here for about 6 months in Kansas. Yeah, exactly. As a matter of fact, closer to my paternal grandmother in particular.
Okay.
And then secondly, yes, you're right. I am with my colleague here at Red Hat, Jason Dobies, also from the OpenShift advocacy team, the co-author of Kubernetes Operators from O'Reilly, which came out in March in paperback and is obviously available at Amazon and O'Reilly's online learning platforms. And as you mentioned, I'll be doing some follow-on trainings through O'Reilly, long-form operator build and distribute training sessions with them over the course of the summer. So prior to that, I was responsible for documentation at CoreOS, and I've been working on operators for a long time in terms of the lifespan of a technology project or product. So the ideas kind of have their origins in 2015 and 16 at CoreOS and how we were automating a Kubernetes distribution. And after the acquisition, the work on them has continued apace at Red Hat. And today we're going to talk about some of the cool things that come out of that work, which is basically catalogs of applications for easy installation and full lifecycle management on OpenShift Kubernetes clusters and on any Kubernetes cluster. Is exactly what we'll look at today, is how to bolt on these App Store, app distribution, and lifecycle manager components to any Kubernetes cluster that you're running, whether it's OpenShift or not. So, without a lot of further introductory material, let me jump over to some slides that I think will help guide us in our discussion. And before I dive into demos, which is actually most of what we'll be doing today, so you'll get to see me fumble around on the keyboard a lot and not be able to find my browser tab, because everyone enjoys that. I do want to run through just a little bit so we get some context of what is an operator and why do I care about these things. And last thing I want to mention before I move out of this intro is at the end of this, I'll even give you a link for a complimentary copy of mine and Dobie's Kubernetes Operators book. And we'll have links to that in the closing slide, so stick around till the end if you want that. So, what are operators and why do you care about them? Let's get cracking on that topic. Why should you care about operators? Some of you have probably heard of operators in the last year or two and know something about their relationship with Kubernetes and how they extend the platform and what their aims are. Let's take a look at those aims so we can understand why we would want a catalog of applications packaged as operators to run on an OpenShift or a Kubernetes cluster. In short, I think that operators are important because any application in any system has to be installed and configured over time and managed, and it's state preserved, user preferences, the data that it's storing. All of those things are necessary whether you're deploying a browser on a desktop computer or your laptop, and you think about things like Google Chrome and Firefox, and for a long time they've been delivering automated updates over the air. Their installers manage not just the initial deployment of that web browser, but continually phone home, check for updates, and apply them while preserving the state for a browser, the user's preferences. Apps on your mobile device likely are installed and provisioned in the same way. You probably go to an app store for your device or one of several app stores for your device if you're on Android. Choose applications, install them on your phone, and those applications are kept running, kept up to date, your configuration is preserved, their state is preserved through upgrades and through their entire life cycle over time. Clusters are no different. You have to deploy applications on a Kubernetes cluster. You got to keep it running. And while Kubernetes provides the groundwork for that, for stateless apps, we'll look at exactly what operators add to that. And then over time, you've got to keep it patched and up to date. And the reason for that is a corollary to this idea that we have to install, configure, and lifecycle manage any application on any platform. Patching is critical to security. It's really the best weapon we have in the continuing arms race of vulnerabilities being discovered and patches being released to mitigate or ameliorate those vulnerabilities. So if you can have up-to-date software, you have the minimal baseline for combating security vulnerabilities and security concerns. Anything that isn't automated is slowing you down. And if you don't have a way to automate that management of a deployment and an application's entire lifecycle and applying security updates to it, you're spending a lot of human time that could be spent inventing or innovating, doing rote tasks, or like what Google's SRE concepts often define as toil, work that could be automated to free human resources to do more interesting, more innovative, or more judgment intensive tasks by giving work to computers that computers would like and letting them automate things like application updates. That theory underpins the automatic updaters that we know on our mobile phone apps and web browsers. Operators, and especially what we're going to focus on in this talk, the Operator Lifecycle Manager, the Operator Hubs, and the software catalogs built around deploying and distributing operators are an application of that same theory of deploying and managing the whole lifecycle of an app on Kubernetes clusters. So quickly, Kubernetes is a cool open source orchestration system. We all know and love it because it lets us define resources in a fairly simple way, and it lets us do that declaratively. We ask for what we want, and the cluster takes actions to make them real. Kubernetes is the declarative platform. So because of that, it's actually really easy to manage, deploy, and scale stateless apps up and down and recover them when members of them fail. Because this application, if you imagine something like a simple static HTTP server, is basically fungible. If I have a pod running a web server and it's just serving static files on client requests for those file names, if that server falls over or I need to scale it up to 3 or 4 or to answer a massive new incoming load of visitors, it's really, really easy for Kubernetes to do that because it doesn't need to know anything about that web server's internal state. If one of those web servers falls over, I can just bring another one up. If I need 4 instead of 2, I can just ask for 4 in a declarative way and the platform can bring them up. In fact, it's so easy to manage scaling and replication of stateless applications that the kubectl command has a scale subcommand built right into it. Let's say I'm running 1 copy of that static web server we just imagined. Well, if I want 3, I just have to ask for them. Again, Kubernetes is a declarative platform. So when I do that, I make a request through my kubectl client to the API and say, hey, scale up our simple static web server. The cluster takes a look at the Kubernetes takes a look at the cluster and sees that the real world actual state or status does not match my desired state, or what we often call specification in Kubernetes terms. And when it notices that, it takes actions to make the real world state match my desired state. In this case, because it's just a web server, we add a couple of pods. Easy to do, easy to manage, and doesn't require Kubernetes to have any specialized knowledge about that web server. In fact, we could have had an Nginx fall over and replaced it with an Apache. So long as it serves that HTTP protocol and knows that same set of files, it can continue doing its job. It is stateless. Unfortunately, most apps aren't stateless. Most applications, somewhere along the line, store data, a user preference, details about your session when you're visiting a website, or more traditionally and more meatily, databases, file systems that underlie and make data persistent that software programs are processing. So most applications have some kind of persistent state, whether it's mission critical data in a database or on a file system, or even if it's just pieces of session data that make revisiting a website a pleasant experience for users. We maintain state with things like databases and file stores, and on Kubernetes, deploying a database continues to be really easy. You just create a deployment with some database image that you know and love, and so I want to run my DB, and now I have a single instance of it running on a cluster, and maybe I provisioned a volume for it to store its data on. In other words, even just to run this single instance of a database, because it has persistent state, my life got more complicated. But beyond that, most of these kinds of things actually have their own notions of clustering, authentication assets that different members of that database or file system cluster need to join that cluster. In other words, running a database, keeping it running over time, especially if you start to consider backups and upgrades and other common production concerns, must-haves, table stakes. Running a database, keeping it running, managing its whole life cycle is harder than running a stateless app. And Kubernetes has less tools to help directly manage, recover, and scale these kinds of applications because necessarily, to be a generalized design, it doesn't have knowledge of MySQL or PostgreSQL or a Ceph cluster's internal state and how they relate, how different nodes within that database or file server cluster relate to each other, how their persistent storage on disk works. All of those are concerns that usually a human operator has to manage for a database. Often he or she's called a DBA, and they know how to take these clustered apps, resize them, upgrade them, keep them running over time, in short. How do we do that on Kubernetes? How do we teach Kubernetes about what an app's internal state represents and what expert humans who operate that app know about keeping it running? If only Kubernetes knew those things. Operators are a way to teach Kubernetes these things by extending the Kubernetes API. So we're not going to go into a lot of detail here, but suffice to say, the Kubernetes API is designed with an extension mechanism in mind called custom resource definitions. This lets us define new first-class resources in the Kubernetes API, like a database cluster. And it lets us, by programming members of the control plane, custom controllers that do know about the internal state of a particular app that they manage, combine these two things to build a way to monitor, manage, upgrade, and keep an app running throughout its life cycle. So that looks a little bit like this. An operator is a custom controller that watches some custom resources on a Kubernetes cluster. The pattern should sound familiar because it's exactly how the stock Kubernetes control plane keeps those stateless applications that we were talking about running, scaled, and recovered from failures. What we do is replace a piece of the control plane with custom controller code that knows about our application. That combination of a custom resource and a custom controller that watches it and takes actions to reconcile it is called an operator. Operators give us a way to package human knowledge into a little box that we can ship out to Kubernetes clusters, OpenShift clusters, and any other Kubernetes distributions. That lets us make our DBA replicatable and scalable across multiple sites or growing applications. So operators are automated software managers, and they manage the whole lifecycle of a Kubernetes application. So hopefully now you think they're really cool and you're wondering how you can get them. Well, operators are managed on a Kubernetes cluster by something we call the Operator Lifecycle Manager. The Operator Lifecycle Manager, henceforth OLM, because that's a pretty clumsy thing to have to repeat, is an operator for operators. What an operator does for an app, understands its internal state, manages its life cycle over time, keeps it running, and arranges for its upgrades to preserve its configuration and its state. That's what the OLM does for operators on your cluster. It's like a software package manager that also includes the lifecycle management and upgrade components. In other words, by building on top of the operator concept and the OLM, we can start to construct catalogs of software for easy distribution onto Kubernetes and OpenShift clusters that look a lot like app stores. And it makes it a lot easier for users to self-service when a developer needs a database to underlie an application that he's working on. Operators in OLM and something we built on top of them called the Operator Hub and the Marketplace for Red Hat applications make it a lot easier for users to self-service their foundation software needs. Say I need a SQL database that I'm building a web app on top of. I don't want to have to learn all about managing a MariaDB or a MySQL server. What I really just want is to be able to point my MySQL client library code at some database. And operators make it a lot easier for me to do that because they make installing a database on a Kubernetes cluster where I'm building my Kubernetes native applications a process that looks a lot more like installing a database on your Linux laptop and seeing DNF or aptitude or apt-get update that from a repo of software over time. So it eases the management of these pieces that you need to build your apps on top of. So in other words, you can use operators today, and Operator Hub makes it easy to consume them both on OpenShift and on Kubernetes clusters. So let's get into what I hope is the most interesting part, which is a few demos of what this stuff looks like as we actually use it. So first of all, we've established so far that we've got this concept called operators for packaging up, deploying apps, and managing them and upgrading them over time. And we have OLM that lets us build catalogs of those operators and make them really easy to select from a list and deploy onto a cluster, keeps those operators updated, and lets those operators manage their apps over time. So this is a system we built out. On top of that, we can build nice user interfaces for those software catalogs. Operator Hub is one of those really nice user interfaces for catalogs of Kubernetes operators. Inside Red Hat's OpenShift distribution of Kubernetes, we can see the Operator Hub gives us a really easy way to drill down the software we want to install to support our applications. Let me search for generalized MySQL database. So we have a scalable production-ready Vitest MySQL operator inside of OpenShift. And so this is really cool. If I want to install something, etcd is always a really good example. Inside OpenShift, we've got a little bit of glue that lets us do this almost entirely in a point-and-click way. This warning's telling me that this operator comes from the community and isn't a licensed piece of the software that we ship with OpenShift. But I want to use etcd to back up one of my applications, so I'm comfortable with that. I know the etcd community, and this is an operator I want to install. Within OpenShift, this looks really, really easy. Operator Hub and OLM work on this concept of a subscription. I am subscribing to the etcd operator so that over time I get updates to it. And then in turn, the operator itself manages and updates the etcd cluster I'm going to spin up over time and throughout its life cycle. An etcd cluster has a lot of internal state that it usually takes an expert human operator to keep running. If an etcd member falls over, adding a new member to the cluster requires details about service endpoints and authentication. The operator can provide all those things, keep my etcd clusters running, keep them updated to the latest versions over time, and I can install them just by establishing a subscription that says, I want that thing to run on my cluster, and I want updates to it over time from the Operator Hub. So I'm just accepting the defaults. I'm going to put etcd in one namespace. And now we've got a running etcd operator. We'll see it spinning up here. And I'll actually return to it in just a moment so we can spin up an etcd cluster. Because I want to move on to a key point, which is while we're looking right now inside the OpenShift distribution of Kubernetes at an integrated Operator Hub, you can run OLM and the components that make up the Operator Hub catalog, the Operator Hub itself, or your own software catalogs, not just on OpenShift, but on any Kubernetes cluster, because it's open source software that you can easily bolt on to your own Kubernetes clusters, whether they're open source whether they're OpenShift or not. So we've taken a look at Operator Hub inside of an OpenShift that comes out of the box. But let's say I'm running a Minikube as a developer, building a couple things on my laptop to do a test and development cycle on a new app. Operator Hub at operatorhub.io packages that same ease of installing or filtering, selecting, and installing operator-backed foundation software on any Kubernetes cluster of sufficient version. So let's say instead of a full Vitesse production environment, I want to spin up a MariaDB, so I've got a MySQL API to develop against with an app that I'm working on, I'm building on my laptop, and I'm using Minishift to give me a Kubernetes cluster in a VM on my laptop and to be able to develop against the Kubernetes API. So I'd really like to have an easy MySQL database without figuring out myself how to deploy a pod or how to deploy a container that I find in some container registry. How do I provision it with storage? How do I keep it running over time? And instead, I'd really like to be able to use Operator Hub the same way I just saw it used inside of OpenShift. That looks really neat. But what I have is Minishift here on my laptop. So actually, oh, sorry, not Minishift, Minikube. It's a historical error I've made many, many times, both saying and talking. Minikube. So in other words, just plain vanilla upstream Kubernetes in a VM on my laptop, not Minishift, not CRC, not OpenShift. So I wanted to take a look at what version of Minikube we're running and show that we've got a cluster running here. And if we take a look at the version, I happen to be running a Kubernetes version 118 cluster. And I can show you by taking a look at the namespaces that I don't have OLM running. I don't have any of the mechanisms I need. So how far am I from right here from deploying an operator the same way we saw inside of OpenShift from Operator Hub? Well, it turns out I'm not very far at all. While I don't have the glue that makes the installation entirely point and click, we've boiled this down to a really simple set of instructions. Now, a lot of folks with security wisdom are going to notice that I'm piping curl to bash in this first step. I want to point out that if you go over to the Operator Lifecycle Manager GitHub, you'll find the step-by-step instructions for doing this, and you can examine the YAML before applying it. But we have bundled it up for convenience here so that even if I don't already have the Operator Lifecycle Manager, I can deploy it on my cluster right along in the same stream of instructions that are going to help me deploy my database server. So I just grab my command here, and what this is going to do is deploy two pieces of YAML that actually deploy the Operator Lifecycle Manager on my Minishift cluster. And as this comes up, we can already see it happening because I'm going to have a couple of new namespaces, the OLM namespace and the operators namespace. Take just a moment on Minishift for the operator that actually comprises the custom controller for OLM to spin up, and now we're done with that. And we can move on to actually deploying a MariaDB MySQL server from the Operator Hub catalog at operatorhub.io onto any Kubernetes cluster. So again, we're going to apply a little bit of YAML that defines our MariaDB deployment, where its persistent storage is, and the policies of the subscription we want to make to the MariaDB element in our software catalog, which in this case is Operator Hub. So I can actually just create these resources. And now again, I'm going to have a new namespace, which will be this one for my MariaDB operator. So let's take a look at what's running in there. And we can see that we have the MariaDB operator is spinning up. Now this is a key distinction. The operator supervises your MariaDBs. So MariaDB is not inside this operator. This operator is instead going to spin up a MariaDB server, or if we make the request, a MariaDB cluster. In this case, we're just going to bring up one node so that we'll have a SQL API we can interact with. So now we've got the operator ready, we can continue with the YAML to actually create a MariaDB database server. So still within Operator Hub, so far I've run two commands. I've deployed OLM on a plain Kubernetes cluster. Now I have all the machinery I need for consuming things from Operator Hub or a custom or behind a firewall operator catalog that you can supply to OLM. And then with another command, I've deployed an operator that knows how to deploy MariaDB databases for me and keep them running. With one more bit of YAML, I can actually say, hey, give me a MariaDB database. So I actually have that baked up here in MariaDB.yaml. And what you can see that's really cool here is notice kind. Because we have an operator and we've made that custom resource definition, what we're defining here, a MariaDB instance, becomes a first-class Kubernetes citizen. I can do kubectl describe and all of the usual suite of API operations against these new custom resources, and we'll look at that actually once we get this instantiated. First of all, let's make a MySQL database with MariaDB here. So now I've just created the MariaDB resource specified in that YAML, and now you can see that on the cluster there is a resource called a MariaDB. We can describe MariaDBs like we do any other Kubernetes resource. We've created a first-class entity in the Kubernetes API that represents custom internal state of an application that we want to run. In this case, a MySQL server, MariaDB, to back a web app that we're developing on our Minikube cluster here. So, what can I do with that thing? Well, actually, if you were on a cloud provider or a larger cluster, you might have a load balancer that you'd put in front of this. But the operator sets us up with a node port that's accessible from within the cluster. Minikube will give us a little bit more glue for external routing to that cluster. So I can actually find out here. Sorry. We're going to describe the I think this is funny. I think I have I got to find our database server so that we can connect to its endpoint. Well, let's look for it in here. So yeah, a little bit of a hiccup here. I have let's review just real quick. That I think what I failed to do is tell this that I want it in my namespace. A classic mistake I make with kubectl on a Minikube cluster as opposed to OpenShift, which will have me inside of a project. So let's try that again. Well, so we're having a little trouble here, but one thing we can show is first-class entities. Because of that, I can actually at least try to look into what's going on with. Now I think I've got. Well, I'll tell you what. I have about 2 minutes, and there's something wrong between my attempt to start a new MariaDB. I have the operator start one for me, and being able to connect to that instance, and I'm not quite able to troubleshoot it live, so let's move on to something a little bit different. Instead of looking at MariaDB, let's do what we did inside of OpenShift and look at the installation of etcd, and then we'll run through a client endpoint on etcd. So what we want to do here is we've already got OLM set up on our Minikube cluster. So we'll just instantiate a etcd cluster in the my etcd namespace, as we can see in the instructions here. There we go. Now we've got the operator. We can ask the operator to make an etcd cluster for us, and that's going to look like this. And again, we're seeing the definition of a first class of a custom resource, the etcd cluster that we're going to ask the operator to create for us. So a little bit of YAML. Now we can look at etcd clusters on our Minishift cluster here, and the next thing we can do is actually spin up an etcd pod quickly that'll let us query that etcd API. So I'm using etcd-cutl, the etcd command line tool, and you'll notice that we have an example client service in the Kubernetes namespace. I don't think we're quite up yet. So I gotta look in the right namespace here. My etcd. So you can see me really sweating this out here because I am having a problem actually getting these operators to instantiate my service for me. And I'm running just short enough of time here that I don't really know how to troubleshoot it and make it work exactly how we'd like. So I'll tell you what.
Because that seems to be the issue, right? The service itself does not seem to be coming up.
Yeah. It's like I'm passing things to the operators I've installed. Like we can see that we've got a MariaDB operator and an etcd operator, but I'm making a mistake somewhere that under the time gun I'm not quite seeing what I'm doing wrong.
There's one very interesting question that I have, and so there are people may be interested in the chat, but there's one thing you kind of hit on really quickly, but it is a bit confusing. There's the creation of the operator OLM, right? Operator Lifecycle Manager, but it also has the concept of a subscription and the CSV, right? And so that CSV is not the comma separated value we all know and love. It's something related to a subscription. Could you talk more about that and how the subscription works within the context of OLM?
Well, yeah, so the subscription, OLM's a little interesting in that I'm not just making a statement that I want to install some application. I'm making, it's maybe analogous to an entry in your local install list for a package manager like DNF or apt. And what I mean by that is I'm not just saying put some bits on my cluster. I'm saying I want to choose to have that application on my cluster, keep it running over time, consume updates to that potentially from a list of channels like, say, alpha, beta, release, for example, that I might choose from to control the cadence of update releases that are automatically applied. In other words, the subscription represents not just the application, but a commitment to managing the lifecycle of that application over the future, right? So that's what I think distinguishes it from just looking at one CRD where I'm subscribing to the operator. The CRD or the custom resource that I then name and try to create, and that I'm having a little bit of trouble then finding the service for back here on the cluster, is the application itself. The subscription is a subscription to the operator. and continuing updated versions of that operator. So does that make a little bit of sense?
It does, and because so from the user's standpoint, they should be thinking in terms of, I got the OLM installed, that gives me 2 new namespaces, and there's certain pods in those different namespaces that are created, but there's also the concept of a subscription that you have to also use, right? If, in other words, if you don't subscribe, you don't get anything. And then once you have your subscription in place and all that, then you actually might have to instantiate the thing, whether that be Knative and Knative serving, the MariaDB. In other words, it's like a 3-step process, not a 2-step process. And I think it's
that's certainly one way to describe it. And so what the thing that you're getting in return, the trade-off there is this idea of keeping that application running over time, of getting updates for that application. And it's actually making a subscription is a lot like downloading an app on a mobile device from an app store or installing Google Chrome on a desktop, in that both of those installations, through their own application-specific mechanism, when you install them, you're making a commitment to take updates to them, or that is to say, the provider's making a commitment to provide updates that preserve your preferences and your tabs lists as versions are upgraded. So when you install Google Chrome, you basically are installing a subscription to Google Chrome. The difference with OLM and with Operator Hub or different catalogs built on top of the OLM machinery is that there's one universal mechanism, like a package management system for a whole operating system, that governs these subscriptions and your updates across those subscriptions, as opposed to every application figuring out a custom internal way that it manages deploying itself and applying updates to itself.
The one thing as it relates to the thing you're trying to debug right now, I don't know if you want to spend more time trying to work on it. We'll give you some more time. But where are the logs, right? So that if the service didn't launch, the operator seems to be real, and you got the right CR in place, right? But where are the logs for the operator? That's a common question I see for people using operators.
And so one of the things I was trying to do, and I have to admit to, I was expecting certain problems. When you get an unexpected problem, it can make you flail a little bit, or at least it can make me flail a little bit. One of the things I was trying to do was actually, at least through a backdoor, is show that. And what I mean is, we were looking at kubectl describe on these different resources that we created. So let me share my screen again. So one of the things you notice is, well, let's stick with etcd for the moment, right? I've defined this thing called an etcd cluster, and I have asked the operator to create an etcd cluster. And I think actually that you, by asking me about subscriptions, may have told me what I've done wrong here, but so there's a little bit of their thing hidden. So let me try to scroll this up. So if we're looking here, the problem is when we have one of these that's working, we would have what amounts to the first level of the log here in the events for that resource, in the same way that we have events for any other Kubernetes resource. Like, one of the things I can do is get events cluster wide. For instance, like, these are all the events that are going on in the cluster. So when I can look at that same event stream for an individual resource, and that's what I'm doing when I look at describe and then actually look at events. So wherever I've missed my wiring here, and I apologize for that, the operator isn't taking actions to actually bring the members of this cluster up, and so we don't have any events here, which means I then move my search out to a wider array and start trying to look at events across all of the namespaces. So these are all of the events that are happening on the cluster, and the tail of the logs here at the bottom. And like a stack trace, I start working backwards up through this to figure out what step I missed along the way.
And also for certain operators, if I could find the operator pod, like if I remember the name of it or what namespace it's in, because they are in different places, right? The operator pods themselves. Then sometimes you can just get the logs out of that, and there'll be interesting things in there.
Oh yeah, there's the kubectl logs command, right? Where if we want to drill all the way down to the pod level, I can look at just the logs that pod is producing. So we have this myetcd namespace. We actually only have the operator pod running in there so far, but because it's a pod, we can just get its logs. Oops. So which containers logs do I want?
Yeah.
Which is just going to be for the operator itself. Now this is showing for the operator itself the leader election among the 3 pods that are implementing the etcd operator. Yeah, Burr, I have to admit this is a failure of my ability to think on my feet, but this is another machine.
And by the way, there's a great tip. There's a tool you can use to make the namespace sticky, like OC Project, but in the
Yeah.
Kubernetes land. Yeah, Kubernetes it's called. Wonderful tool.
Indeed. I'm pretty sure on this machine it's called a state. My sessions use it, not on TP. So, here's the thing. I'm not going to subject everyone to watching me bang my head against trying to figure out what went on here. I think we've at least successfully illustrated 2 points, which is that we can install OLM and we can get operators spinning up. I'm making some error that I'm sure after this I'm going to be pounding my head on the desk realizing how dumb it was because I've just missed a step along the way.
Right.
One thing I want to point out is that you don't see anything dumping in the logs and a bunch of its unexpected events happening. Literally nothing's happening, and it's because I've missed a step in my what I thought was an extremely well rehearsed list of steps that we were going to do to show that. Nevertheless,
Nigel says you'll figure it out about 30 seconds when we
Exactly. It'll be the second we hang up, and then I will be like, "Oh, I never even loaded. I didn't put the subscription." So yeah, we'll look into that. No, I want to encourage everybody, nevertheless, even though that was a demo misfire in some ways, we did see the OLM machinery running on a plain Kubernetes cluster. We saw how we can find items from the OperatorHub.io catalog to deploy software there. And I don't want to make the OLM folks look bad by me having simply forgotten to do something. So I'll work on that, and we'll come back for an update, and we'll talk about maybe building a little LAMP stack or some kind of web application stack directly out of Operator Hub.io.
Yeah, Quentin thinks it was just a namespace missed. Right,
I think I did, and I think I got myself crossed up and sweaty and frustrated trying to figure out which namespace, because you notice there are etcd clusters, right? Like when
well, no worries.
So yeah, I have to walk myself backwards through that and figure out what I did.
Well, I put some links in the chat for YouTube. So the free ebook that you mentioned earlier, as well as access to the Katacoda, meaning you can actually run one of these clusters and try some of these scenarios out yourself. And then, of course, you guys have seen the Operator Framework, hopefully, IO website, so you guys have access to those. And he's got those shared. Fantastic. So I pasted most of those links into the chat, so you guys have access to them and click and go. The slides will be shared on the main site at the URL you're normally sitting at, or in the email confirmation email. And that will be something you can have after the fact. And then I'm sure we'll figure out this bug at some point. And then you can follow Josh on Twitter. I did put down his Twitter handle. I'll do that one more time here at the end. Yep. And then he can tweet about it, and you can actually harass him online through social media. How about that?
I'll take my lumps on it, because I'm already starting to form an idea of where I went wrong there. I think we're in a namespace called but anyway.
Appreciate it. It did give us a chance to ask some questions and show a little bit of debugging, because one of the issues is, where are my logs? What the hell? I've had that same issue myself.
And I think to me, it continues to be one of the coolest things about operators is how I can make a little bit of YAML that's a custom resource, and then all of a sudden I have this thing called an etcd cluster or a MariaDB, and it's an actual Kubernetes thing that I can use all the usual Kubernetes tools to interrogate. And we did at least get the opportunity to check that out a little bit in dumping the event stream from an etcd cluster custom resource, and then walking back up to the events cluster wide, and then back down to the logs of the individual container within the etcd operator pod. So
James says it's okay. There are no CIOs here. So thank you very much for that, James. All right. So James, Nigel, DJ, Maddie, Quentin, thank you all for your chat. It was actually good to talk to you guys here today, but we need to get off this call. I thank you all so much for today's session. It was a lot of fun. Josh, awesome stuff. We'll follow you on social media, follow you on Twitter, just like we do Donald Trump, right? Think of it like that. And then hopefully get nice insights from you over time. But thank you so much, and we're going to get out of here now.